Hello Year 9, this is your lesson on literal equations. So, what are they? Now, sometimes we have equations in which some of the coefficients are pronumerals. So it's not just one letter or two letters, there's multiple letters. And these are called literal equations. We need to be told which pronumeral we're solving for. So let's have a look at some examples. So I'm solving ax plus b equals c for x. That means I want to end up with x equals something at the end. Now I do exactly the same thing as I would do if these were numbers. I start by subtracting b from both sides. So I get ax equals c subtract b. Then I want x to be by itself. At the moment it's being multiplied by a, so I'm going to divide both sides by a. And I need to write c minus b over a. If you wrote c minus b divided by a, using order of operations, that means we do b divided by a and then we subtract the answer from c. That's not what we want to do. It's c minus b divided by a. We don't like how this looks though, so we write it all as a fraction like this. Let's look at another example. Okay, so here I've got brackets, and if you remember back to the equations with brackets lesson, there's two different ways we can deal with this. Firstly, we could divide both sides by a first. That would give me x plus b equals c over a. Then I can subtract b from both sides to give me x equals c over a minus b. Alternatively, I can expand the brackets first. ax plus ab equals c. Then I can subtract this ab from both sides. So ax equals c minus ab. Then I can divide by a. Now these two solutions do look different, but they're not. If I were to separate this, so this is just me explaining, c over a minus ab over a, you can see that we have a common factor of a in this fraction. So that's c over a minus b, which is the same as what we have here. Now, both of these are valid. They're perfectly acceptable to use. Sometimes one will be more useful, sometimes the other will be. The book uses only this one in its example, and so probably the solutions in the book will be in this form. However, if you want to have a go at this one, that's fine as well. Pause the video now while you have a go at question 1 from exercise 5F. Okay then, in this example you can see we're solving for x still, but I've got an x on both sides of my equation. What I need to do is first collect all of the x's on one side. So I'm going to start by subtracting nx from both sides. Then I only want x terms on this side, so I'm going to add n. Now I have a common term of x in both of these terms, so I can factorise into a single bracket. Then the x is multiplying this bracket, so I can just divide by this whole bracket here. Now, let's say I decided to instead subtract mx from both sides. I would then want to get rid of this m here, so I would subtract m. I've got x's in both of these terms, so I would factorise. Then I would divide by n minus m. Now again, we have two things here that look very different. But if I take my fraction on this side and multiply it by -1 over -1, so I'm just multiplying by 1, I'm not changing its value, but my negative n becomes positive n, my negative m becomes positive m, my positive n becomes negative, my negative m becomes positive. And hopefully n plus m is the same as n plus n, and minus n plus m is the same as m minus n. So with literal equations, you might get a different answer to what's in the back of the book depending on what steps you chose to take. Your answer, if it's correct, will be equivalent to the answer in the book. But if you're unsure whether they are, then you can check with your teacher. Pause the video now while you have a look at these questions, and then I'll show you how to do these on your CAS. Okay then, so we can use our CAS to help us with this. So let's have a look at this equation here. Remember on your CAS to solve, you go to Menu, and then Algebra, and then Solve. So I'm going to type in my equation, but I need to make sure I tell the CAS that this means a times x. So I type a times x plus b equals c times x plus d. Now, I need to also tell the CAS what I'm solving for. If you've used it for solving before, even if you typed in an equation like 5x equals 20, you still need to tell it to solve for x. So we write comma, we write x, and it gives us this, which hopefully is what you got. You may have got something like d minus b over a minus c as well. There's different ways we can give answers. So why do we need to tell it to solve for x? Well, if I told it to solve for a, then that gives me a different solution, obviously, because now I've got a equals something. So it's really important both. Oh, I'll show you the other thing as well. So if I don't put the multiplication sign in, if I don't tell the CAS that my a is multiplying my x and my c is multiplying my x, then it gives me this. This is not your answer. This is your answer. So be very careful that you put a times x and so on. Thank you very much.